All right, for the first question, we have this function. It's a cubic function, and we have to figure out what the transformations are. So we have to remember y equals a times x minus h, this would be cubed, plus k. Kind of remember that. This one doesn't have a number inside the parentheses, really. So if we were to think of this and kind of make it similar to this notation right here, we would say this is y equals 3 times x cubed minus 4, like that. So that means that the x does not have a coefficient like inside of the parentheses, so there's no horizontal stretch or compression. But we do have a number in front, which means we have a vertical stretch of 3. We have no left or right shift, but we are shifting up or down. It's down 4. So vertical stretch of 3 and then shifted down 4. So stretched vertically, shifted down 4. The answer for number 1 is D. All right, an object is launched straight up from the ground level with an initial velocity of 50 feet per second. So they give us this. We're going to go ahead and graph this. And it says, when will the object have a height of 28 feet and be traveling downward? Okay, so in y equals, I'm going to go ahead and graph this. And typically for me to figure out like how big of a window I need, I look at the table. And I know that I'm looking for a height of 28 feet. So here the x or the t represents the time, the h or the y represents the height. And so since I want a height of 28 feet, my y values are going to be what's important. So 28 is not the highest off the ground it gets. It looks like it gets a little bit more than 30. So, and that's around, that was an x value of like 2 or something. So I'm going to change my x's to maybe be -5 to 5, and then I'm going to make my y's go up to at least 40. And so the reason I'm doing that is so that I can see everything on my screen. So now if I want to see where on the graph we have a height of 28, again, height is the y value, the x value is time, the y value is height. So I'm going to say height of 28. And then I can see this is when it first reaches a height of 28 on its way up in the air, and then this is the height of 28 on the way down, and that's what they wanted when it was traveling downward. So now I'm going to do second trace, and I'm going to find the intersection of those two equations. Now remember, when you find the intersection, you don't have to have the cursor perfectly on the intersection, it just has to be close. So the intersection is at 2.394. All right, number 3, what is the range of the function? So if we think about this, we have a parabola. It's written kind of in a different order than we're used to. That's how we're used to seeing it. So this is the vertex form. That means that the vertex is at -3, -5. And this -2 means that it's upside down. Now, you don't have to do this problem by hand. You can do this problem just by graphing it in your calculator. So I'll go ahead and make my window normal again. So there we can see our vertex left 3, down 5. We can see that the -2 made it upside down. So I know that the range is going to be from -infinity up to some value. And so that means A is out. -infinity to infinity is out. So here I just have to see if it's -infinity to -5 or -infinity to +5. And it's going to be -5 because that y coordinate right there. And so this is -infinity to -5. All right. A wind that is blowing from the northwest toward the southeast can be represented by a vector. the vector has an eastward component and a southward component. If the eastward component has a magnitude of 5 miles per hour and the southward component has a magnitude of 15 miles per hour, in what direction is the wind blowing? All right, so first we want to figure out the angle of our vector. And so it says from the northwest toward the southeast. So from the northwest toward the southeast would be this way. So that's a 315-degree angle if we're thinking about measuring it, using that standard position for our calculator. And so we know we're going to have some sort of magnitude times cos 315i plus some sort of magnitude times sine 315j. And then it says the eastward component, so that's the horizontal component, left and right, has a magnitude of 5. And the southward component, or the vertical component, has a magnitude of 15. And so they want to know what direction the wind is actually blowing. So this is kind of like our x, this is kind of like our y, and we're going to do tan inverse of y divided by x. And so in your calculator, you do need to make sure that your calculator is in degrees. And then we're going to do tan inverse of 15 sine 315 over 5 cos 315. So negative 71 degrees, that means that we're in the fourth quadrant, which makes sense. The fourth quadrant is where we're southeast. And so I have to think about measuring that as an angle, one of those south, whatever degrees east angles are. So that means we're measuring it this way. That's negative 71. And we want to say it's south something degrees east. So I need to figure out how many degrees are in between here and here. So I'm going to add 90 to that. So that's 18.43 degrees east of south. And notice they did put the common wrong answer in there. They did put the 71.6 in there, even though that's not the right answer.